All right, the instructions for this section say find the zeros of the function, then sketch the graph of the function. So we're going to find the zeros like we did earlier, but then we're going to use the zeros, find we use those roots, those answers to plot the graph real quick. So here we go. Just like before, just instead of a 0 over here, we have an f of x. So here we go. F of x equals, and then we'll factor this one out. Divide out the biggest thing you can. So I'm going to divide it on x squared. So that's x squared minus x minus 12. And since x squared is alone, two things that multiply to 12, negative 12 but add to negative 1. So f of x equals x squared. Those two numbers are negative 4 and positive 3. So x minus 4 and x plus 3. And when I set those equal to 0, x squared equals 0, x minus 4 equals 0, and x plus 3 equals 0. And now, equals 0. And now, because we have an x squared still left in, it is important to notice this one is actually going to be a double root. All right? Because at two spots, x is going to equal 0. So we've got x equals 0. We're going to do 0 again. We're going to do a positive 4, and we're going to do a negative 3. All right? And I'll show you why that's important in just a second. All right? The other two things we need to know from this is what's the y-intercept? Okay, well the y-intercept, so when x is 0, y in this case is 0 because it's not adding anything out here. It's like having a plus 0, so that's your y-intercept. Right? And last but not least, we need to know, well, how many turns could it possibly have? Well, could it possibly have as many as 3. Oop, I want to erase that. I don't want to erase the 3. And the leading coefficient is positive, so I'll put LC is positive. Alright, so just like before, we got all the information we need to give a rough sketch of this. We've got all the roots. Why did I just erase that? There we go. We got all the roots. We have the y-intercept. We have the leading coefficient, and we have the number of turns, the maximum number of turns. Okay? So here we go. First things first. We need a 4, a negative 3, and a 0. So we got more on the positive. So if I use this to draw, I'm going to draw it like this. And so I've got my negative 3, I got my 0, and I got my 4. Those are my points. All right, and we know the leading coefficient is positive, so it's going to come up from the right. This one's going to be a little bit different. Because it has a double root, it's not going to cross through at 0. It's going to come to it and touch it and bounce off, whether that's from above or from below. I'm guessing it's going to be from below, but if you have a double root, if you ever have the same root twice, you're going to come up to it and bounce off of it just like that. So leading coefficient is positive, so we come up from the right. We go through the 4. We're going to make one turn. We're going to bounce off the 0. That happens to be a second turn. Make a third turn and go through the last root. Just like that. All right? And that's a rough sketch. Again, we're not looking for utter perfection. You may end up drawing it a little bit shallower. You may end up drawing it very steep. Again, we're not looking for where exactly is everything. We're looking for a rough idea of what this graph is going to look like. Okay. All right, number 8. Same idea. Factor it out and go. So if you want to try the rest of these, go for it, because I think you can do them. But I'm going to do them anyway so that we're all on the same page. So here we go. F of x equals, I can divide out an x on this one. So x, negative 4. Actually, I'm going to divide out a negative x. Not that it matters a whole lot, but It just makes life easier for me. I like my leading coefficient to be positive. So 4x to the third power minus 12x, no, not to the third power, 4x squared, goof, minus 12x plus 9. And this one we have to do the other way because there's a 4 in front of that x squared. We got to think two things that multiply the left, two things that multiply the right, and the outside inside adds up to that negative 12 in the middle. So 2 times 3 is 6. Yeah, so I think it's going to be 2x minus 3 and 2x minus 3. Let me double check that right quick. So again, just to show you what I'm doing, 2x times 2x is 4x squared. Okay, so my left multiplies the left. Negative 3 times negative 3 is negative 9, so the right side multiplies the right. Pardon me. The way you check is the outside inside. So 2 times negative 3 is negative 3. So negative 6x. And the inside, negative 3 times 2, that's again negative 6x. And those add up to negative 12x, which is our middle term. Okay? That's how we're doing it. There we go. And again, we got the same thing twice. So we have another double root. We only have to solve for it once, but remember, it's a double root still. So we've got f of x equals, well, for the first one, it's going to equal 0. For the second one, we set it equal to 0. We are going to get positive 3 halves. All right, and remember, that one's a double, so I'm going to write it twice just so I don't forget it. All right, and then from here, my leading coefficient is negative. We need the y-intercept, which again, the y-intercept is 0 because there's nothing being added out there. And last but not least, we need the number of turns. Since the degree is 3, the maximum number of turns is 2. I'll go ahead and put max out here. Max number of turns is 2. And we're probably going to use it. Alright, so let's go ahead and graph this. We'll make our graph. And since all we have is a 3 halves, we're going to put our 0 right here. And I'm going to count by halves. So let's make that 1, we'll make that 2. So 3 halves is 1, 2, right there. The leading coefficient is negative. So it's going to come up from the right. This one's a double root, so we're going to bounce off of it, make 1 turn, 2 turn, and go back up through the 0. Through the y-intercept, which actually is 0. All right, and there you go. All right, number 9, numero 9. There's nothing to divide out here, and since there's 4 terms, I'm going to try factoring by grouping. So the first one I'll divide out in x squared. So that's x squared. I'm sorry, not x squared. X plus 4. The next one is I can divide out a 6. And I want to divide it in a negative 6, so I get the signs right. 24 divided by 6 is 4. Yay! It worked. So I've got f of x equals, I got my x plus 4. And then I get an x squared minus 6. Which, oftentimes you think, oh, it's a difference of squares. I still got an x squared, I got a negative, but 6 is not a perfect square. But you know what? We can still do it. It just looks a little uglier. So we got f of x equals x plus 4. And we don't know what the square root of 6 is, so we're just going to write x plus the square root of 6 and x minus the square root of 6. All right. So when we set these equal to 0, we're going to get x equals negative 4 plus and minus the square root of 6, which that's what about 2 point, I'm going to guess 4. I really don't know. Well, 3 squared is 9, 2 squared is 4, so it's somewhere between 2 and 3. Anyways, so we got our roots. Your y-intercept is negative 24. because that's the one that's by itself. Your leading coefficient is positive. LC is positive. And the number of turns, the max number of turns, since the degree is 3, the max number of turns is 2. All right. So let's graph this sucker out. So we need a space for a -4 and a space for a 2 to 3-ish. So what did I just do? And since our y-intercept is -24, I'm going to leave a little space on the bottom. So we'll do this -2, -4. That'll be 2, that'll be 4. And we'll make this, I don't know, 10, 20, 30. We'll say that's 20. Alright? So we get an idea what the scale is. So 24. So let's plot this all up. I've got -4 as a y-intercept. I got somewhere between -2 and -3, so just put it there. And somewhere between +2 and +3, so we'll just put it there. And then we got -24. Oops, I should have a negative in front of the 20 right there. Not +20, it's -20. So we'll put a dot right there. And the leading coefficient is positive, so we come up from the right. So 1 turn, 2 turns, hit all our points. And so it's going to look something roughly like that. All right, last one. There is nothing to divide out on this one, so we just got to start. And there's no number in front of the x to the 4th. The leading coefficient is 1. So 2 things to multiply to the left are x squared and x squared. 2 things to multiply to 81 but add to -18 are -9 and -9. -9 times -9 is 81. Add out to -18. Good. And those are both difference of perfect difference of squares. So we got f of x equals x plus 3, x minus 3. That's for the first one. And again, we've got x plus 3 and x minus 3. We got that one. So we have, for this one, when we solve, we'll have 2 -3s. So we got a -3 and a -3. And we'll also have 2 +3s. So we got a +3 and another +3. All right, so we have 2 double roots on this one. And everything else we need. The leading coefficient is positive. The max, I'll put MT, max turns. The max number of turns is 3 because the degree is 4. And the y-intercept is 0, 81. So we're really going to have to scale back this for this one. So I'll make this like this. So 1, 2. What's going on? There we go. That'll be 3. That'll be -3. Let's see here. 20, 40, 60, 80. That'll be 80 right there. And 80. So we got +3 for one double root, -3 for another double root, and we're going through 81, which I'll just make it look a little bit above. And leading coefficient is positive, so we come up from the right. We come up from the right. We bounce off our first double root, go through that, and then bounce off our second double root. And I didn't even count my turns. 1, 2, 3. Good. So we did it right. And there you are.